Now, according to the previous statement, if A is a subset of B and X does not belongs to B, it implies X does not belongs to A. So, out of 200 peoples, we have 90 people exposed only for chemical C1, 20 people exposed to only for chemical C2. So always remember that is the cardinality of the set A union B or the cardinality of set A intersection B is always less than your universal set. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today in this session we are going to take up certain problems on sets which leads to the applications of set theory. Now let us take few concepts of sets before starting with the applications of set theory. So here we have a question. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Now here the first statement states an element X belongs to A and the set A belongs to set B, then the element X belongs to set B. So let's see by taking an example. Now assume that the set A contains the element X and A belongs to B means let B be an element containing Y as well as X. So clearly X is nothing but your A, set A. Now set A is in B but not the element is contained in B. That means here clearly we can see here X is not an element of B but set X containing X. Set containing X is an element B but individually the element X does not belongs to B. So therefore clearly we can see the given statement is a false statement. Next one, if A is a subset of B and B belongs to C, then A belongs to C. Let me take set A as 1 and 2. Let me take set B as 1, 2, 3. Clearly we can see here A is a subset of B. They have given here B belongs to C. That means B is an element inside set C. That means let C be the set containing the set B 1, 2, 3 and any elements like 4, 5, etc. Now clearly here B belongs to C. But look at A. What is set A? Set A is the set containing 1, 2. There is no element 1, 2 inside C. So clearly they have given A belongs to C, but here A does not belongs to C. So therefore the given statement is a false statement. Next, if A is a subset of B and B is a subset of C, then A is a subset of C. Now according to the given statement here we have two statements. Suppose any element X belongs to A, then this implies X also belongs to B because they have given A is a subset of B. Now since X belongs to B, this also implies X belongs to C because they have given B is a subset of C. Now assume this X belongs to A and X belongs to C. So that implies A is a subset of C. That means if any element is contained inside the set A, then that element is also inside set C. Therefore, A is a subset of C. So therefore, the given statement is a true statement. Next we have A is not a subset of B. B is not a subset of C. Then A is not a subset of C. Let me take an example. Set A has an element 1 and 2. Set B as an element 2 and 3. Set C has an element 1, 2 and 4. Now according to this given statement here, A is not a subset of B. See here, because 1 does not contains in B. So clearly we can take an example where A is not a subset of B. And 2 is in C but 3 does not contain in set C. So therefore clearly we can see here B does not contained in C, or we can say B is not a subset of C. But see here the elements 1, 2 are present inside the set C. So this implies what? A is a subset of C. So whenever A is not a subset of B, B is not a subset of C, A is not a subset of C they have given. So this statement is a false statement. That means there can be a set where A can be subset of C also. So the given statement is not true in all the cases. Next. If X belongs to A and A is not a subset of B, then X belongs to B. Clearly, if they have given X, A is not a subset of B. So according to these two statements, if X belongs to A and A is not a subset of B, this implies X does not belongs to B. But they have given X belongs to B. So therefore, this is a false statement. Next statement, A is a subset of B, X does not belongs to B, then X does not belongs to A. So now here, if A is a subset of B, what does it implies? X belongs to A such that X belongs to B. But they have given X does not belongs to B. That means X should not contain in A also. So therefore, the given statement is true statement. So this is a true statement. Next question. Show that if A is a subset of B, then C minus B is a subset of C minus A. So I need to show that C minus B is a subset of C minus A. So given A is a subset of B. Now let me take an element X belongs to C minus B. What does this implies? What does the difference of set indicates? It belongs to C. Here X belongs to C, but X does not belongs to B. This is what the difference of two sets indicates. So the element is present in C but not in B. Now we can also take this in this form. X belongs to C but X does not belongs to A. Why? Because they have given A is a subset of B. Now according to the previous statement, if A is a subset of B and X does not belongs to B, it implies X does not belongs to A. Look here we have if A is a subset of B and X does not belongs to B, then X does not belongs to A also. So therefore, here I can rewrite the statement like this. Now when X belongs to C but X does not belongs to A, that implies X belongs to C minus A. So first we have X belongs to C minus B. Now we got X belongs to C minus A. So therefore we can write C minus B is a subset of C minus A. Next question. Show that the following four conditions are equivalent. That means all the statements are one and the same. So the first statement says A is a subset of B. The second statement says A minus B is empty. The third statement says A union B is equal to B. And the fourth statement says A intersection B is equal to empty. Observe the last two statements. I already told you in the session of subset, that is whenever A is a subset of B, that means all the elements of A are contained in B. This implies the union of these two sets will be the B and the intersection of these two sets will be A. Because since A contained in B, the common elements between A and B is the set A. And when I say union, all the elements in A and B are in B. So therefore, the union of these two sets is B. So these two statements implies that A is a subset of B. And coming to the second statement here, A minus B is empty. So why A minus B is empty? Because we know that A is a subset of B. That means an element A, let me take an example, set A as AB and set B has ABC. So now let me see here. Clearly we can see according to the first statement, A is a subset of B. It satisfies. Second statement you see A minus B. A minus B means element in A but not in B. We don't have any element inside A which is not in B. So therefore it is clearly an empty set. And the third statement you can see there A union B is nothing but ABC which is nothing but B. And fourth statement A intersection B, which is nothing but common elements in A and B, that is AB. So what is AB? AB is set A. So clearly we can see all the four statements implies the condition that A is a subset of B. So therefore, the given statements are equivalent. Next, is it true that for any sets A and B, power set of A union power set of B is equal to power set of A union B? Justify your answer. So let us take an example and let's try to verify this statement whether it is true or not. So let me take set A containing an element A and set B containing an element B. And let me take A union B. What is A union B? The elements containing in A or B. That means we have two elements, that is A and B. Now let's write the power set of these sets. What is the power set of A? So power set of A is first is empty set and then the element A. So the set containing all the subsets of the given set is nothing but the power set. Now power set of B is again first empty set and then the element B. Now let's write power set of A union B. What are the power sets of A union B? Clearly empty set is an element. Set A containing set B and set containing A and B. So these are the elements of a power set of A union B. Now let's see what is power set of A union power set of B. So power set of A is set containing empty set and set A. And union, here it is again empty set and set containing an element B. Now writing the union of these two sets, we will get empty set, set containing A, set containing B. So clearly this is not equal to power set of A union B. Why? Because we don't have an element A comma B which is inside power set of A union power set of B. So clearly the given statement is a false statement. Next, there are 200 individuals with a skin disorder. 120 had been exposed to chemical C1, 50 to chemical C2 and 30 to both the chemicals C1 and C2. Find the number of individuals exposed to chemical C1 but not chemical C2, chemical C2 but not chemical C1, chemical C1 or chemical C2. So first, let's see the number of people exposed to different chemical. So now let's write number of people who are exposed to chemical C1 is 120 and number of people who are exposed to chemical C2 is 50 and number of people who are exposed to both. When I say both, in sets, it indicates the intersection of the two sets, that is C1 intersection C2. So we have 30 people. Now what are we supposed to do here now? So first we need to find out the people who are exposed only to C1 but not C2. That indicates the number of people who are exposed to C1 but not C2. So that means the difference of C1 minus C2. The second one is chemical C2 but not C1. So that is number of people who are exposed to chemical C2 but not C1. So that indicates number of peoples who are exposed only to C2 not C1 implies C2 minus C1. And chemical C1 or chemical C2 always or represents the union of the two sets. So therefore here we need to find out number of people who are exposed to chemical C1 or chemical C2. So this again we can find with the help of a Venn diagram as well as your formula method. So first let's see with the help of a Venn diagram. So here it's a universal set. So this is the number of people who are exposed to C1 and this is number of people who are exposed to C2. Now how many people are exposed to both the chemicals? That is 30 members which we will write here. How many peoples are exposed to chemical C1? 120 members. So out of 120 members, I have already written 30. So the remaining 90 people are exposed to chemical C1. Next we have chemical C2, 50 members. Already 30 are written. So 20 are remaining. So these many peoples are exposed to chemical C1. So I already told you, when you subtract the intersection part from one circle, it represents only the people who are exposed to C1, and here it represents only the people who are exposed to C2. So that is, here this shaded part indicates the number of people C1 minus C2, and this shaded part indicates the number of peoples C2 minus C1. So therefore, and this is your C1 intersection C2. So therefore, here you can observe, so 90 people are exposed to only C1 and 20 people are exposed to only C2. Now, how many people are exposed to any one of them? That is 90 plus 30 plus 20. So, in total, 140 members. So, 140 members are exposed to C1 or C2. But there are 200 individuals. So, out of 200 individuals, 60 people are not exposed to any one of the chemicals. So, that means they are neither exposed to chemical C1 nor exposed to chemical C2. So, out of 200 peoples, we have 90 people exposed only for chemical C1, 20 people exposed to only for chemical C2, 30 for both. So, in total, 140 members are exposed to any one of the chemicals. 60 members are not exposed to neither C1 nor C2. Now, let us write the answers here. So, from the diagram, we can clearly see it is 90, here it is 20, and here it is 140. So, suppose if they ask you that how many people are not exposed neither C1 nor C2, then you can clearly write 60. But in total, it is 140 plus 60, 200 individuals. Next question. A market research group conducted a survey of 1,000 consumers and reported that 720 consumers like product A, 450 consumers like product B. What is the least number that must have liked both products? So there are 1,000 consumers. So that means the number of people who are liking the products is 1,000. That is, universal set is given. And number of people who likes products A is 720. And number of people who like product B is 450. Now we need to find what is the least number that must have liked both the product. That means we are supposed to calculate A intersection B. So now let us write the formula. We know that N of A union B can be written as N of A plus N of B minus N of A intersection B. So it is 720 plus 450 minus A intersection B. We neither know this, so let's write as it is. N of A union B is equal to 1,170 minus number of people who likes both the products. Now this is what we got, and we know that A union B is a subset of U. A union B is a subset of U. Also, A intersection B is a subset of U. And when I take the cardinality, number of A union B can be less than or equal to universal set always. So that is, the maximum value that A union B can take is the universal set. So therefore, this implies, so the maximum value N of A union B is less than or equal to 1,000. So that is, the maximum value this can take is 1,000. Suppose if I take number of people who likes any one of the products is 1000, then the least value that A intersection B can take is 170. How? Because if I substitute here this as 1000 here, then we will get number of A intersection B as 1170 minus 1000. This is the maximum value that A union B can take. So therefore, the least value where we can expect is 170. So always remember that is the cardinality of the set A union B or the cardinality of set A intersection B is always less than your universal set, because both are the subsets of universal set. Hence, A union B can take the maximum value, A intersection B can take the minimum value there. Thus, 170 is the least number of people who likes both products A and B. Next question. Out of 500 car owners investigated, 400 owned car A, 200 owned car B, 50 owned both A and B. Is this data correct? So let us write this in the form of a statement. We have N of A union B as N of A plus N of B minus N of A intersection B. And there are 500 owners, so therefore let me take the number of universal set is 500. Now we are finding the number of people who owns car A or car B. So therefore here we have here 400 plus 200 minus 50, where we will get it as 550. That is the maximum number that A union B is taking is 550. But we know that A union B is a subset of your universal set. That means the cardinality of A union B must be always less than or equal to the cardinality of universal set. That means it should be less than 500 or equal to 500. But here it is greater than 500. So therefore, the data given is incorrect. Next question. In a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, 3 read all the 3 newspaper. Find the number of people who read at least one of the newspapers, the number of people who read exactly one newspaper. So here we are supposed to find the number of people who read at least any one of the newspaper. So that is A union B union C. That is the people who read A or B or C. So here, since the newspaper are given the name as H, T and I, we can take this in the form of the number of people who read H or T or I. So this is the first thing we need to find. And we need to find the number of people who read exactly one newspaper. That means we need to find the people who read only H, only T, only I, and then add it to find the total number of people who read exactly one newspaper. So again, instead of statement problem, we can use the Venn diagram method so that we can easily find out the answer here. So since we have 3 sets here, so let me take 3 sets here. So let me take this as newspaper H, newspaper T, newspaper I. Now while filling the Venn diagram, always fill the very common part in the 3 sets. That is, how many people read all the 3 newspaper. So we have 3 people who read all the newspaper. The next statement is 8 read both T and I. So T and I means these 2 circle. So this will be the common portions for T and I. And already 3 is written. So there are only 5 people who read T and I. The next statement is we have 11 read both H and T. So when I say H and T, so this portion will represent the people who will read both H and T, and 11 minus 3 remaining we have to write, that is we have 8. Next, we have 9 read both H and I. So H and I is here. So this is the common portion or common set between H and I. Already 3 is written, so 6 are remaining. So therefore, we can see here 9 read H and I, 8 read T and I, 11 read H and T. Now let us write the circle with whose people read only newspaper H. How many people will read newspaper H? 25 people read newspaper H. But out of 25 inside the circle, we have already 17 people who read newspaper H and the remaining people are only 8. So we have here 8 plus 8 is 16, 16 plus 6 is 22, 22 plus 3 is H. Number of people, 25 people who read newspaper H. The next is we have 26 people who read newspaper T. So out of 26, we have already have 8 plus 3, 11, 11 plus 5, 16. So 16 means we are left with 10 more people who read the newspaper T. Next again we have 26 read newspaper I. So we have 6 plus 3, 9, 9 plus 5, 14. So out of 26, we still have 12 people who read newspaper I. Now the first thing is find the total number of people who read at least one of the newspaper. Add all the numbers here. So that is for the first one, it is 8 plus 8 plus 10. Next we have 6 plus 3 plus 5, 6 plus 3 plus 5 plus 12. So clearly we will get 52 people. So therefore there are total 52 people who will read either newspaper H or newspaper T or newspaper I. Now the second one is I need to find out the number of people who read exactly one newspaper. Now when you take here, always the intersection part represents the people who will read both the papers, or the middle one represents who will read all the 3 papers. So therefore here the shaded region which you can see is the only number of people who read a single newspaper. So that is 8 people read only newspaper H, 10 people read only newspaper T, 12 people read only newspaper I. So therefore, the number of people who read exactly one newspaper is 8 plus 10 plus 12, that is equal to 32. So 32 people will read only one newspaper. Next question. Now, the same question can also be solved with the help of a statement. So we can see the alternative method here also. That is, we have a formula for the cardinality of 3 sets, that is A union B union C. So which can be written here in the form of N of H union T union I. And this is given by N of H, N of T, N of I minus N of H intersection T minus N of T intersection I minus N of H intersection I plus N of H intersection T intersection I. So using the formula for the first one here, so this can be written as 25 plus 26 plus 26 minus 11 minus 8 minus 9 plus 3. So when you evaluate this, you will get the total value as 52. That is, there are 52 people who will study any one of the newspapers. Now coming to the second question, we need to find the number of people who will study or read only exactly one newspaper. So therefore, we can subtract from the union in this form, that is H union T union I minus N of H intersection T minus N of T intersection I minus N of H intersection I plus 2 times N of H intersection T intersection I. So which can be written as 52 minus 11 minus 8 minus 9 plus 2 times 3, and when you solve this, you will get the answer as 30. So therefore, total there are 30 people who will read exactly one newspaper. So this is all about the chapter sets. We'll meet you in the next session with a new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.